IPSV is a software tool that has been developed to be used to file and maintain all data that is generated during the design phase of safety valves. In an industrial asset, the specification sheets of its pressure safety valves can come from different sources, providers, and periods of its life cycle. Although all of them probably do follow some industry standards, they may have quite a heterogeneous content. IPSV has been designed so that an engineer can create and update in a systematic way and in accordance with API's methodology the specification sheets of safety valves and the sizing basis of design, as well as those for the headers related to these valves. In this way, the information is kept centralized and standardized in an electronic repository, easily accessed through its user-friendly interface. In this tutorial, we're going to show several examples of how IPSV can be used. Firstly, let's see how a service is added. A service being understood as the group of PSVs that protects a piece of equipment or groups of them. On the Services tab, the Add icon is clicked, which in turn will open the form where we can enter the general information about that service. That is, its name, in this example Service 1, and the P&ID where the service is located, together with the description of the main equipment that it protects, as well as its design pressure, in this example 13 bar G. When the service is saved, it is stored together with the appropriate project name and revision number. When a service is selected, Service 1 in this case, and the user clicks on it, a new form appears where the relief valve, one or several, which is going to be associated with that service is or are added. To add a PSV, the cursor is moved over the PSV tag and we right-click. A new form opens where the general information about the valve will be added. Tag name PSV90 in the example, where it discharges, if it is a spare valve, or if it has an associated rupture disc. It also contains the fields associated with the valve size and its piping. When designing safety valves, all possible scenarios that could lead to an equipment overpressure must be considered, and the areas required for the safety valves that protect the equipment in every scenario should be calculated. IPSV allows for the storage of all sizing scenarios. In the example being demonstrated, two scenarios have been added. When a scenario is selected, a new form opens where all information regarding the calculation of the valve area for the corresponding scenario can be added. This form is found on the Results tab. Scenario A in the example is a blocked outlet situation, while Scenario B corresponds to a fire situation. In addition to the Results tab, there are three others: Piping, which allows access to the hydraulic calculations; Warnings, which highlights non-conformities with the design recommendations; and Notes, which describes the events happening in the equipment while the overpressure scenario is occurring, and thus establishes the basis of design to determine the flow and the transport properties of the fluid that the safety valve has to relieve. Many software tools exist for the calculation and design of relief valves. Some of them are commercially available, while others are developed internally by engineering companies. IPSV has been developed taking this into account, thus facilitating the importation of information related to the sizing of relief valves and all associated piping. The commercially available process simulator Aspen HYSYS from Aspen Tech Inc. contains a feature called Safety Analysis, which allows the calculation of the area necessary for a relief valve for different scenarios. The next part of the tutorial will show how the information generated in Aspen HYSYS can be imported into IPSV. Here we can observe an Aspen HYSYS model, where the required area for PSV 100 PSV 90 is calculated. In the example, the area is calculated for two scenarios, blocked outlet and fire. Each scenario contains the information necessary for the calculation of the required area for such a scenario. Aspen HYSYS keeps all this information for the calculation of PSVs in an MDB file with the same name as the HYSYS case. From the IPSV main menu, it is possible to access the Import from Aspen HYSYS option. This option allows us to navigate the computer folders in order to find the Aspen HYSYS file that contains all the valve information. The Import option automatically transforms the information existing in HYSYS into a format readable by IPSV. We can now see how the information about PSV 100 PSV 90 has been imported. Such a valve has an opening pressure of 11.34 bar G, and the installed orifice corresponds to the size E. In the lower part of the form, we can also see the information related to the PSV inlet and outlet pipes. If we click on scenario A, we can access the form where the blocked outlet scenario information is to be found. It is now possible to see that this case concerns a two-phase fluid in critical conditions, which has used the mixed AB method in HYSYS to size the valve. The scenario contains all the information necessary for the sizing of the valve: opening pressure, maximum allowed overpressure, 10% in this particular case, the back pressure from the header, and the pressure generated in the tailpipe, as well as the thermodynamic properties required for the calculation method, and the area necessary and the area installed. Finally, the Notes tab can contain the description of the events that occur during a scenario. In the last example in this tutorial, a new scenario is imported from HYSYS, and then the IPSV database is updated with the new data calculated for the new scenario. First of all, the scenario is added to the Safety Analysis Aspen HYSYS feature. The scenario is given the name Scenario C that will simulate a general power failure situation. Before this, the required relief load and its transport properties have been already determined in Aspen HYSYS in accordance with the basis of design of such a scenario. Finally, we move into IPSV and import the Aspen HYSYS generated new data. A new scenario should appear in IPSV Scenario C with all the information related to this scenario. As a final remark, it is worth mentioning that although this tutorial has been showing how to modify and update information related to 3 scenarios of a single relief valve, the power of IPSV resides in its ability not only to manage, in a single database, all the information related to the hundreds of relief valves that might exist in an industrial plant or in a project, but also to generate reports in printable Excel sheets, fully customizable by the end user.